So now that you've learned what the future API looks like, you've seen a simple example of how to program with Java futures, let's take a step back and talk about the pros and cons of doing things with this model. And the key point I want you to come away with from this discussion without spoiling it with the giving the surprise up front, Java futures are very limited. And so even though there's a handful of benefits, the limitations pretty much outweigh the benefits by and large. So what are the pros and cons? Some of the benefits is you might be able to leverage the parallelism on a given platform more effectively with only a handful of threads. And that's because you're going to basically kind of queue up all these asynchronous operations in the thread pool, and those threads can then be kept highly utilized. And as the results finish, you can then go pick them up and do something with them. So let's assume that we're going to search for a bunch of words in a bunch of input strings, and we're going to asynchronously submit all these tasks. Yes? That's correct. Yes. So the question was, what does this diagram mean? Let me explain, because I've been kind of glossing over this. So this thing here would be some kind of thread pool. It could be various types of things. It could be a fork join pool or whatever. It could be executor completion service. It could be the executor service, whatever you want to have. And so what happens here is that a client thread submits a task. That task is going to end up on a work queue. And so if a bunch of threads come along, they will all submit tasks. They will end up on the work queue. The client thread will get back a future. So all the client thread or threads will get back the futures. And it could be one thread. It could be one client thread just saying submit, 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 submit. That'll build up a whole queue of these runnables or callables here. And then the threads in the pool will run in, various ways to do it. There's a hungry puppy fashion where we pre-spawn a whole pool of threads and they just wait on that queue, and as work shows up, some thread grabs it and does its thing. There's other models where if there's not an available thread on the queue, a new thread could be started. There's different variants of that, kind of like the fork join pool we talked about. And so as these threads pull work off the queue, they then go ahead and run the result to completion. And then in this particular case, they put the results on something called a completion queue, and the client can come along and pick it up and do something with it. But the key point here is that the client doesn't block waiting for the result. The client invokes the operation, and then results come back through some other means. So Java futures allow a bunch of things to be queued up, a bunch of things in the pool. Threads in the pool can run those things, and then as they finish, futures will be completed, and then one or more client threads can get the results. Does that answer the question? Okay. Yeah, good question. So here you can see that we're going to submit the work here. In this particular case, we're submitting a Lambda expression, but you could submit various things there. So we submit this. And depending on how you set up the thread pool, it can be automatically tuned. It could be a fixed size thread pool. You, as the developer of this abstraction or the program, can select the way in which you want the pool to behave. That's really a topic for next semester's class, but at least for now, you can have different ways of implementing thread pools. And then results can be taken from the queue of completed futures whenever the client feels that it needs to be in a position to take the results. And as you can see, you could even have one thread submitting results and another thread getting the results. You could have multiple threads submitting the results. You could have multiple threads you could have multiple threads submitting the requests. You could have multiple threads reaping the results and taking them. It's up to you to decide how you want to organize all that kinds of stuff. But the point here is that you can have a lot of CPU utilization going on because you're queuing up the work on this work queue, and then that is asynchronously processed with respect to clients who are submitting new requests for work, new tasks, and other clients or the same client that's getting the results of those computations. So the whole thing could be running in parallel in a very nice and scalable way. So that's a cool thing. Getting things to run scalably by keeping the processor cores utilized is a good thing. Another thing you can do with futures is you can block until the results of an asynchronous task is available, either like this with an unconditional block, or like this where you can poll or timed block. So those are good things that futures provide. Another thing you can do is you can cancel something that's running. You can test to see if something has been canceled. You can check to see if something's done. Lots of options you have there to manage the life cycle of a task that's running asynchronously. However, there are limitations with Java futures, and that's the problem, right? So the main problem with Java futures is that their feature set is very, very limited. So one thing you can't do with a classic Java future is you cannot explicitly complete it. So once it starts to run, you cannot say this feature is done. You have to rely on other Java mechanisms like future task to finish up and complete or trigger the completion of the future. That is definitely a topic that's for next time. So we'll talk about that in next semester. Another problem is you cannot chain classic Java futures together so that as asynchronous results finish, you can automatically invoke completion methods to handle those results and potentially kick off another asynchronous operation. So you have to do these things one at a time. There's no way to be able to have a fluent interface of futures. Yet another thing is you can't trigger them reactively. You have to either block or time wait or poll. And this is awkward because you don't really quite know exactly what to do. Blocking is usually a bad idea because you would be waiting indefinitely, and if that asynchronous operation never finishes, you'll just block and waste the client thread just waiting for something that'll never happen. And even if you try to put a timed operation in here, that is still problematic. How long do you wait? Do you poll, which is kind of busy waiting? Do you wait for a certain amount of time? If you wait for up to 10 milliseconds, is that the right number? How do you know what the number should be? It's really, really tricky to program with classic Java futures correctly. Another problem with classic Java futures is you can't treat a bunch of futures as a collection. So here's a simple example. If we have two futures, future 1 and future 2, and we go ahead and submit them so they're running, we have to wait for them in a particular order. We have to say future1.get followed by future2.get, or future2.get followed by future1.get. We can't say, I don't care which one finishes first, give me the result. Give me the result of whoever finishes first. So, at least not without doing a lot of extra programming. So it's very difficult to have a collection of futures and then just take whichever one comes back first. There are ways to do this, but they're awkward and require additional programming and overhead. So as a general rule, it's awkward and it's inefficient to compose multiple futures together in any kind of fluid way or fluent way. And not surprisingly, these limitations with Java futures are what motivated the Java developer team to create the completable futures framework in Java 8 and beyond. So that's what we're about to talk about now. We're going to talk about futures and how they overcome the limitations. We're going to talk about completable futures and how completable futures overcome the annoying limitations with the classic Java futures. And I think you'll see once we're done describing the completable futures framework, you'll be like, why would anybody ever use futures? And the answer is, you probably shouldn't, unless you've got some kind of legacy code that has already baked this in for a long time.